Circular queue implementation of a FIFO buffer. So FIFO buffers are just memory elements. So whenever we're gonna talk about them, we're gonna have to keep in mind that they do utilize memory arrays. So the concepts of depth and width of a memory array still applies. However, what we're gonna be doing is we're gonna move the linear organization of this memory array. We're just gonna make it into a circular queue. Okay, so what we'll have row 0 in here, and that is here with row 0. So the content of that row 0 is just, I'm representing it here. So row number 1, we're going to see that the content of that row number 1 is here. Row number 3 or 2 is actually represented in here, and so forth. And of course, because it's circular, you're going to see that the last row, let's assume that this is row number 7, which is here, is going to be virtually connected to the first one, which is row number 0. Okay. In reality, we'll be using memory arrays, the 2D memory arrays. It's just we're going to think about them as a circular queue as opposed to a 2D or a linear memory space. Okay. In this figure, I'm just showing you the depth, and I'm just showing you a FIFO buffer that has between 0 all the way to 7. So it has 8 rows. So the depth is 8 rows. This figure is not showing me how many bits can I fit per row. So in here I have 3, but this particular location 1 or 2 or 3 can have 8, 16, 32 bit, depending on the type of FIFO we have. And we're going to see later that the FIFOs will have different sizes and they can accept different word length. Okay, so they could word width basically. Okay, so they can accept something that is 8 bits, 16 bits, and they can have more than 8 locations. But for simplicity today, we're just going to start by talking about a FIFO buffer that has about 8 locations. Okay, so in addition to just organizing it in a circular queue, what we'll be showing you as well, I'll be showing you a couple of pointers, and these pointers are called the write pointer, and the other one is the read pointer. Okay, and initially, I'm just going to initialize them to point to location 0. And what they effectively do is they tell me where, let's talk about the write pointer, for example. It effectively tells me that this particular location is primed to write a new word. So if you have to push something new to that FIFO buffer, it's going to be pushed in here. So let me show you a few examples of what's going to happen with these pointers, okay? Let's assume that I want to write a word. So what happens is you're going to write a word. That word in here, I'm going to highlight it in yellow as if it's basically written. So whenever you see a location that has a yellow highlight, that means there's some sort of a word, a valid word stored in it. And of course, what happened is that pointer actually moved to the next location, telling me location number 1 is currently primed to write a new word. Now, the read pointer, on the other hand, is actually pointing to the head of the FIFO buffer. Is pointing to where the very first word that was pushed to that buffer. So as long as it's pointing to it, and because we're constructing something that is the first word fall through, you're going to see that this particular word is available at the output of the buffer. I'm not showing you this here, but if you remember, the FIFO buffer have some sort of a output in here and an input in here. So this particular word is, or location 0 is whatever is available here. It does not have to be necessarily location 0. It's whatever the pointer is pointing to. Okay. So let's see another maybe right position. Okay, and you can see in another right position, now I have location 1 is written to, and right actually moves to the next location, and so forth. So let's do another right in here, for example, and you're going to see now I have 1 word, 2 words, and 3 words written, and the right pointer is pointing in here. So what happens if we actually issue a read command? You're going to see that the read command now moves from location 0, it will move to location 1. Okay, so now the head of the FIFO buffer is actually location 1. Okay, so this is why we organize it in a circular fashion. It's actually easier to deal with pointers than actually to deal with linear and thinking about it linearly. And that's why I'm not showing you what's happening linearly, because it might be a little bit on the confusing side. This is just a lot easier. Okay, so what about location 0? What happened to the word that was in it? Technically speaking, I moved the read pointer in here, so this particular word now is available at the output, and whatever word was stored at location 0 is currently still stored in its location. It's still memory. I didn't remove it. I just removed the pointer to it. So what I'm doing is I'm making it available if I want to overwrite it. Like, let's assume that the right pointer was pointing at 7. It will know that it can actually write it 0 in the next time. Okay, so let's go again, and we're going to do another write, and 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 another write. What I'm doing in here is I'm filling it. So now what I do is I have a full location. And what I want you to pay attention to is at full, you're going to see that the read pointer and the write pointer are pointing to the same exact location. Okay, the same exact location. Good. So I can tell that it's actually full, that the FIFO is full, and I shouldn't be able to write anymore. Okay, what happened is the one before in here, let me just do that. What happened is this is the write buffer in here. That's the previous slide. You can see that it's here pointing in here telling me that I can actually overwrite that 0. This is the first one we read when I told you that you can write it, and yes, it's available. So the previous value was still stored in here, but it's available. So if I issue another write command and I put something at the input of the FIFO buffer, it will overwrite that particular location because it's currently marked as available. Okay, and whenever you do this, you're going to see that the write pointer now is pointing to the same as read pointer, and this is actually a valid point. So you're going to see that the FIFO have a status flag that is called full that tells me it's full, meaning you cannot write anymore. Yes, the write location is writing to location 1, but this is not an available location because the FIFO buffer is full, and you're going to have to wait till I actually empty it a little bit. So how do I empty it? Well, I'll issue a read command. And now when I issued the read command, the read pointer actually moved from location 1 to location 2, marking location 1 as available. Of course, now if I issue a write command, it will actually fill that location and move in here and tells me it's full again. But what I'm going to do is I'm going to empty that FIFO buffer, and I want you to pay attention to one thing and another again. Okay, so I'm just issuing a bunch of read command. I'm just emptying. So now the FIFO buffer is empty. And what I want you to pay attention to is the location of the read and the write pointer. They're actually located at the same exact location when they were full. They're exactly the same. And basically they're pointing, and now I have a command that basically, or a status that tells me that it's empty. And the status that is empty actually affects the read. Okay, and it tells me, well, yes, you're pointing to a location in here, but the location does not have any valid word in it. So you can't technically read because it's empty. If you're reading gibberish. Now, if I am about to implement this, the most difficult part is actually figuring out when it's empty and when it's full. And one might think, well, I just have to test if the read pointer and the write pointer are pointing to the same location. And initially they were writing at 0, 0 in here at the very, very beginning, which when it was empty because it was initially. So whenever read and write pointer are pointing to the same exact location, no matter where that location is, could be at 0 or could be at 1, I know that it's either empty or full. But the problem is figuring out which one it is. Okay, so in here, what you do see is you do see pretty much the same exact FIFO, the same exact read pointers, okay, and write pointer location. They're both pointing to the same exact location, but one indicates that it's full, the other one is indicating that it's empty. And implementation wise, what you're going to see later in a different video is we're going to keep a couple of FIFO, a couple of flip-flops actually. One flip-flop is going to actually indicate the status empty, and the other flip-flop is indicating the status full. So whenever we're reading and writing, we're going to keep track of those to make sure that we indicate where the full is and where the empty is.